Hi there. The question we are going to explore today is who the unborn baby really is. And we'll try to answer this question uh, taking a journey through science, philosophy, and cosmos. From the very beginning, the unborn is not a passive organism waiting to come into the world and then participate in this world. Scientific research shows that the prenate is a conscious participant in life, perceiving, sensing, and responding right from the beginning. Every heartbeat, every movement, every subtle reaction reflects a being actively engaged in the process of becoming. When doing clinical work using prenatal psychology principles and practices, we get answers from the person in front of us in the room about things, events, situations, atmospheres that were even before conception. This send, if we look at the prenate in terms or under the lens of the sensory development and early response, we'll see that touch is the earliest sense to form. Touch means contact. And it is later than the initial contact on a consciousness level, perhaps on an atomic or molecular level, when the prenate becomes, let's say, 8 weeks, when we see this, or older than that. So touch is the earliest sense to form. We know that tactile receptors begin developing around 8 weeks, especially around the lips and face, spreading to palms by 12 weeks, and the abdomen by 17 weeks, and by mid-third trimester, the prenate can perceive a full range of sensations, including pressure, heat, possibly pain. The auditory system becomes functional between 18 to 20 weeks, allowing the prenate to detect low-frequency sounds like the maternal heartbeat and voice, and by 25 to 29 weeks, the auditory system is fully operational, and the prenate can distinguish the mother's voice by around 33 to 41 weeks. The taste and olfactory systems are also active. prenates taste flavors via the amniotic fluid as early as mid-pregnancy and show facial expressions indicating flavor discrimination, laughter face, for example, something they like, carrot, and cry face for something they do not like, something sour or bitter, around 32 and 36 weeks. Voluntary movements emerge around 16 weeks, including thumb sucking, limb flexion, and coordinated actions rather than mere reflexes. And the palmar grasp reflex can be observed in utero as early as 16 weeks, reliably by 28 weeks, reflecting an organized neural response. Prenates actively respond to maternal vocalizations, and one study found increased mouth opening when the mother sang a lullaby, la, as part of a nursery rhyme suggesting early mirroring behavior. They also display differential heart rate and movement responses to the mother's voice versus unfamiliar sounds or recorded voices. For instance, heart rate increases in response to the mother's voice and decreases to unfamiliar voices. Prenatal exposure to auditory stimuli, music, speech, can induce learning and memory traces which persist postnatally, suggesting that prenates not only perceive but also process and remember stimuli. Brain imaging has identified cortical sensory activation in a response to the maternal voice between 33 and 34 weeks, indicating recognition and processing at a higher neural level. By 24 to 36 weeks, prenates exhibit facial expressions suggestive of distress or pain, complex pain, distress, gestalt expressions, indicating a maturing capacity to respond to stimuli at a more integrated behavioral level. Thalamocortical connections, essential for conscious sensory processing, generally form between 22 to 34 weeks, commonly by 29, 30 weeks, and enable sensory information to reach cortical areas. The evidence clearly shows that the prenates are far from passive in the gestation period. Even before birth, they exhibit sensory perception, responsive behavior, and learning ability. And while questions of consciousness still remain complex in terms of neurodevelopmental research, the growing body of studies supports that a prenate is an active participant, a being that perceives, responds, reacts, decides, begins forming memory and relational patterns while still in utero. A prenate is a being who creates themselves, orchestrating the symphony of cellular growth, tissue differentiation, and organ formation. Mammalian embryos display a remarkable capacity for self-organization, maintaining developmental trajectories even after experimental perturbations. This resilience arises thanks to feedback between mechanical forces, biochemical signals, and the cellular heterogeneity, all working in concert to ensure correct patterning and structure. In avian models like quail, studies show that mechanical self-organization plays a central role. Local contractility activates long-range tension controls, and together these orchestrate tissue flows and gene expression patterns vital for embryo formation. During the early mouse embryo development, the differences in physical forces help determine which cells become the trophectoderm and which become the inner cell mass. Changes in mechanical force distribution, cell polarity, and activation of molecular pathways guide these self-fate decisions. This demonstrates the developing being's inherent ability to use internal mechanical and chemical information to shape their own identity and structure rather than passively receiving external directives. Self-organizing tissue patterning is a widespread developmental feature. Cells can spontaneously form spatial order through local interactions mediated by diffusing signaling molecules or mechanical forces. Reaction diffusion models help explain how uniform cell fields can develop intricate patterns such as those seen in organ formation or early embryoic specification. In vitro embryoid models crafted by pluripotent stem cells recapitulate aspects of early embryogenesis. These models demonstrate endogenous self-organization. Even without maternal or environmental input, the cells form spatially patterned structures akin to natural embryos. Right after conception, the prenate must organize the nuclear architecture from scratch. New research shows that the prenate employs multiple redundant epigenetic mechanisms to restore proper nuclear organization even when initial patterns are disrupted. This highlights the capacity to self-correct and self-regulate at the molecular level during the earliest moments of life. These these insights collectively affirm that the developing prenate is not merely a passive outcome of genetic and maternal inputs. Rather, the prenate is an active architect equipped with robust self-organizing capacities. From the early stage of nuclear structuring to tissue differentiation and organ formation, the prenate dynamically creates corrects, integrates multiple developmental processes, emulating a self-conducted symphony of life. A prenate is also a relational self, already engaging with the mother, father, the environment, cosmos, through subtle communication, resonance, and memory. Prenates show differential heart rate responses to familiar versus unfamiliar voices. As we said earlier, heart rate increases when they hear the maternal voice and decreases when they hear a stranger's voice or sound, signaling recognition and memory-driven engagement. With repeated exposure prenatally, for example, when the father reads something on a regular daily basis to the pre-born child, the prenate also responds to the father's voice, although newborns subsequently preferentially orient towards their mother's voice. Perhaps fathers need to take this into account and ask themselves, why is that? Where am I during that early period of life? Am I talking? Am I bonding? And am I communicating? Does my prenate know me? Do I know the prenate, my child? Newborns also recall melodies they were exposed to in utero, adjusting their motor responses upon hearing the melody again. Recognition extends to tastes and smells, and newborns prefer their own amniotic fluid scent and show transnatal memory of prenatal olfactory exposures. Fathers engaging in structural prenatal interaction, for example, speaking, touching the mother's abdomen, even ultrasound, deepen the emerging bond. These sessions encourage sensitivity and strengthen attunement to the prenate being. This reciprocal relationality begins even before conception, grounded in sensory communication, perceptual feedback, and emotional presence. The prenate is a relational self, listening, learning, remembering, responding within a sensory and emotional milieu shaped by parents, family, society, the historical background. Through voice, rhythm, smell, and touch, the prenate engages in a continual dynamic of resonance and recognition, a subtle yet profound dance of connection that begins in utero. A prenate is also the carrier or a carrier of continuity, bringing ancestral heritage. Research has unveiled that environmental exposures can lead to heritable epigenetic changes across multiple generations in model organisms. For example, in fruit flies, maternal egg cells transmit H3K27 ME3 epigenetic marks to the embryos, which are essential for proper development and survival. In C. elegans show inheritance of histone modifications, such as the above mentioned in fruit flies and others across generations, even influencing lifespan. Similar observations and studies have been made related to prenates. Epigenetic marks like DNA methylation and histone modifications, once thought to be wiped clean during early development, can sometimes escape reprogramming. Certain loci resist demethylation and histone modifications in gametogenesis, allowing partial inheritance of methylation patterns, and small RNAs and the extracellular vesicles also contribute to transmitting environmental information through the germline. Although more limited, several human studies provide compelling observations. For example, descendants of Holocaust survivors display altered methylation in genes tied to stress regulation. A study on Syrian families found epigenetic marks linked to trauma in grandchildren of women who experienced violence during pregnancy, among the first human evidence of such inheritance. Other research links the famine exposure, such as during the Dutch hunger winter, to increased obesity and mental health risks in later generations. Researchers emphasize that distinguishing epigenetic inheritance from social, behavioral, or environmental confounders is complex. And some authorities urge caution, noting the need for more robust longitudinal and mechanistic studies to confirm human transgenerational epigenetic effects. Epigenetic and cultural inheritance often reinforce each other. In humans, epigenetically influenced traits, for example, stress reactivity, may shape parenting behavior, which is then passed down culturally. Beyond biology, family stories, rituals, and cultural patterns serve as symbolic carriers of ancestral meaning, shaping identity, values, and direction for future generations. All these together affirm that the unborn baby can be seen as a carrier of continuity, one who physically inherits epigenetic traces of ancestral environments and trauma or health, even as the prenate is shaped by cultural stories, relational patterns passed down through generations. The prenate embodies both inherited memory and evolving potential, standing at the crossroads of lineage and emergence. In the light of cosmological laws, a prenate is a manifestation of universal principles, embodying the laws of polarity, resonance, rhythm, resistance, and more laws, principles that govern creation. Embryogenesis hinges on polarity, the division into distinct axes, such as the animal and vegetal poles in blastula stage prenates, which guide later developmental fate and germinate layer formation. The prenatal form mirrors cosmic dualities, stability and change, symmetry and differentiation, manifesting as the prenate defines the structural and functional orientation from unity into organized complexity. Patterned gene expression in prenates often oscillates rhythmically, such as the segmentation clock in vertebrates, where coordinated cycles of gene activation regulate somite formation. These oscillations traverse tissues as traveling waves. Embryonic tissues can behave as mechanically excitable media, producing propagating waves, evident in mitotic wavefronts across syncytial embryos like Drosophila, for example. Just as cosmic systems entrain via resonance, embryonic oscillators align rhythm and pattern across cells, creating coherence and coordination central to forming body structure. Embryonic development exhibits intricate rhythmicity. Waves of gene expression and cellular differentiation unfold in cycles, tightly controlling temporal and spatial aspects of growth. Rhythm underlies both cosmic and cellular emergence, beat-like cycles of formation, transition, and emergence map from the macroscopic rhythms of star cycles to the microscopic segments of the forming embryo. Developmental processes like symmetry breaking rely on resistance. Initial symmetry must be disrupted to establish polarity and directionality. In embryology, early events like cortical rotation and asymmetric protein localization create biological tension that gives rise to structured complexity. Bioelectric gradients, spatial voltage differences across tissues orchestrated by ion channels act as pre-patterns for gene expression and structural polarity, functioning through mechanisms that both support and constrain growth. Resistance, like a canvas holding form, is what allows polarity, rhythm, and resonance to manifest. Creative emergence thrives in the presence of opposing forces, enabling structure and direction in both cosmos and embryos prenates. Through the cosmological lens, The unborn baby is more than a cluster of developing cells. The prenate is a cosmic embodiment in miniature, holds within self the dynamic tension of unity and differentiation, like the cosmos unfolding from singularity to complexity. Pulses with internal harmonies, echoing cosmic cycles and synchronization that generates structure. It grows through tension and constraint, where creative form emerges from a resistance, just as stars and galaxies emerge from forces in equilibrium. The prenate is a node of unity and multiplicity, where the one unfolds into the many, and the many converge back into the one. Turing's morphogenesis in 1952 tells us that from an initially uniform field, let's call the field the one, teeny fluctuations in interacting diffusing chemicals, morphogens, can spontaneously break symmetry and generate repeating spatial patterns, stripes, spots, segments, the many. This classic mechanism explains how complex form can emerge without a pre-drawn blueprint. Wolpert's positional information tell us that cells read their position in a gradient and adopt different fates accordingly, the French flag model, providing a quantitative link from a simple global cue to multiple differentiated cell identities. And was Waddington's epigenetic landscape allows us to see how a single pluripotent state funnels into many stable cell fates via canalized pathways visualized by a ball rolling down bifurcating valleys, connecting unity of origin with multiplicity of outcomes. Gene regulatory networks, Davidson and colleagues, for example, showed that large, hierarchically organized gene regulatory networks integrate numerous local decisions into coherent organismal form. For example, many cell type programs converging on one viable body plan. This is the systems level return to unity. Beyond the genes, bioelectric circuits across tissues store and process pattern information that coordinates growth and repair, helping distributed cells behave as one anatomical self. Recent work formalizes how such signals integrate information to guide morphogenesis. Kaufman's and Prigogine's programs explain how complex order arises in far from equilibrium systems. Dissipative structures emerge as many parts couple into collective patterns. Embryos are prime exemplars of this physics. global order from myriad local interactions. The prenate begins as a single zygote whose internal dynamics, reaction, diffusion, gradient, symmetry breaking, generate diverse patterns and fates. Through GRNs and bioelectric integration, myriad differentiated cells coordinate into one organism, a coherent whole with stable anatomy and identity. In this light, the prenate is both one and many. The prenate unfolds multiplicity from unity, then continuously integrates multiplicity back into unity, a living node where universal principles of emergence, patterning, and integration meet. A prenate is a living fractal of the cosmos, repeating the patterns of galaxies, atoms, and ecosystems within the formation of their own body. Fractal geometry, characterized by self-similarity across scales, is prevalent in various biological structures. For instance, the branching patterns of blood vessels, neural networks, and the architecture of lungs exhibit fractal-like properties. These structures maximize efficiency and surface area essential for their respective functions. The application of fractal analysis in biology has provided insights into the complexity and organization of living systems. During embryonic development, pattern formation is a critical process. Studies have shown that certain gene expression patterns during development exhibit fractal-like characteristics. This self-similarity suggests that the principles governing the organization of biological systems are consistent across different scales from the molecular to the organismal level. In cosmology, the concept of fractals has been applied to understand the large-scale structure of the universe. Research indicates that the distribution of galaxies follows a fractal pattern up to certain scales, suggesting a self-similar structure in the cosmos. This fractal nature of the universe implies that similar organizational principles apply from the microcosm to macrocosm. The recurrence of fractal patterns in both biological systems and the cosmos points to a fundamental principle of self-organization and pattern formation. The embryo, as a developing organism, embodies these universal patterns, reflecting the same organizational principles observed in larger cosmic structures. The unborn baby can be viewed as a living fractal of cosmos, mirroring the self-similar patterns found in both biological systems and the universe at large. This perspective highlights the interconnectedness of all levels of existence, from the molecular to the cosmic, and emphasizes the universal principles that govern the formation and organization of life. The prenate is a force of becoming, moving through cycles of expansion, resistance, balance, and transformation, just as stars and planets do. Embryonic development is characterized by dynamic cycles of cellular proliferation and differentiation, a process that involves expansion, rapid cell division, and growth during early stages, resistance, mechanical constraints, and biochemical signals that guide tissue formation, balance, coordination of cell growth, and differentiation to form structured tissues, and transformation, morphogenetic changes leading to the development of complex structures. Expansion, resistance, balance, transformation. These cycles are essential for the proper formation of the organism and are regulated by intricate genetic and molecular networks. In astrophysics, cosmic bodies undergo cycles that mirror the processes observed in embryonic development. Stars form from the gravitational collapse of gas clouds, leading to nuclear fusion and the release of energy. Resistance, the balance between gravitational collapse and thermal pressure, stabilizes the star. Balance, equilibrium between various forces that govern the star's life cycle, and transformation. Stars evolve through stages from main sequence to red giant. It may end as white dwarfs, neutron stars, or black holes impacting surrounding planetary systems. Drawing parallels between embryonic development and cosmic cycles, both systems exhibit self-organizing principles where complex structures emerge from simpler rules. Continuous feedback mechanisms maintain stability and guide development, and both undergo transformative processes leading to new forms and structures. The unborn baby in utero embodies the principles of expansion, resistance, balance, and transformation. Processes observed both in embryonic development and cosmic cycles, which highlight the universal patterns governing the emergence and evolution of complex systems. In the light of the 369 framework, we can see that the unborn baby in the first triad, in the position of 3, represents the integration of matter, life, and consciousness, forming a triad essential for human existence. Embryological development begins with the creation of the zygote, the merging of sperm and egg, leading to this single cell that contains all of the genetic information necessary for the development of a human being. Another triad here: egg, sperm, zygote. This zygote undergoes rapid cell division and differentiation, giving rise to the three primary germ layers, ectoderm, mesoderm, and endoderm, and these layers subsequently develop into all the organs and tissues of the body, embodying the material aspect of the triad in the differentiation 6 stage. Simultaneously, the process of embryogenesis is driven by vital forces that guide cellular differentiation and organ formation, representing the life aspect. These forces are influenced by genetic and epigenetic factors, perhaps cosmic factors, which regulate the expression of genes and the development of the organism. The integration of these forces ensures the proper formation and function of the developing organism. The unborn baby exists at the intersection of various dualities, harmonizing these forces into a dynamic balance. One of the most fundamental dualities is the relationship between the mother and the self. The prenate is entirely dependent on the mother, and by speaking mother, the other, for nourishment and protection, yet the prenate also maintains their own genetic identity and autonomy. This interplay between dependence and autonomy creates a harmonious balance that supports the development of the prenate. Another duality is the internal and external environments. The prenate is enclosed within the amniotic sac, surrounded by the mom's body, yet the prenate is also influenced by external factors such as maternal emotions, diet, overall health. These external influences can affect the prenate's development, highlighting the interconnectedness of the internal and external worlds. Furthermore, the prenate embodies the duality of being and becoming. While it exists as a distinct individual from the moment of conception at least, the prenate is also in a constant state of becoming, undergoing continuous development and transformation. This process of becoming is guided by genetic programming and the environmental interactions, leading to the emergence of a fully developed human being. The unborn baby represents a point of completion and renewal in the cycle of life. Each pregnancy is the culmination of countless generations, carrying forward the genetic and cultural heritage of humanity. At the same time, every gestation that comes to a completion is a new beginning, introducing a unique individual with a potential for infinite evolution. This concept aligns with the idea of cosmic intelligence entering human form. Some philosophical perspectives suggest that consciousness is not merely a product of the brain, but a fundamental aspect of the universe that becomes individualized in its human being. From this viewpoint, the prenate is a vessel through which cosmic intelligence enters the material world, carrying the potential for growth, learning, and evolution. Furthermore, the process of prenatal development can be seen as a metaphor for cosmic evolution. Just as the prenate progresses through stages of development, the universe undergoes processes of expansion, transformation, and renewal. This parallel suggests that the unfolding of life on a microcosmic level reflects the broader patterns of cosmos. In this way, the prenate serves as a gateway where cosmic intelligence enters human form, carrying the possibility of infinite evolution and embodying the eternal cycle of life, death, and rebirth. Embryonic development is characterized by self-organizing processes wherein the prenate autonomously generates structures and form through intrinsic mechanism. This self-organization is evident in various stages of development, from the initial cell divisions to the formation of complex tissues and organs. For instance, the formation of the blastocyst, a crucial early stage in mammalian development, is a well-documented example of cell organization. During this process, the first three cell lineage in mammalian development specify and arrange themselves based on cell-to-cell interactions, leading to the formation of a multi-layered structure ready for implantation. Moreover, studies have shown that early embryogenesis exhibits extraordinary developmental plasticity, allowing a correctly patterned embryo to arise despite experimental perturbations. This plasticity undergoes the embryonic capacity for self-organization, enabling the prenate to maintain developmental trajectory even in the face of challenges. The unborn exemplifies a self-organizing autonomous process wherein the prenate actively constructs their own body through intrinsic mechanisms, underscoring the dynamic and autonomous nature of prenatal development, challenging the notion of the prenate as a passive recipient of parental contributions. But let's look at history. In the 19th century, German biologist Ernst Haeckel proposed the idea that ontogeny recapitulates phylogeny, suggesting that the development of an individual organism, ontogeny, mirrors the evolutionary history of the species, phylogeny. Haeckel's theory was influenced by earlier observations by Meckel and Baer, who noted that vertebrates of different species resemble each other more strongly during early ontogenesis than later on. While Haeckel's original formulation has been largely discredited, the concept has evolved. Contemporary evolutionary developmental biology recognizes that embryonic development can reflect aspects of evolutionary history, though not in a direct linear way. For instance, certain embryonic fetches may appear transiently and then disappear, reflecting ancestral traits that have been lost in the adult form. Stephen Jay Gould's work, Ontogeny and Phylogeny, further critiques and refines the recapitulation theory, emphasizing the complexity of the relationship between development and evolution. Gould suggests that while ontogeny does not merely repeat phylogeny, it is influenced by evolutionary processes and can provide insights into the history of life. Comparative studies of embryonic development across species have revealed similarities that support a modified view of recapitulation. For example, vertebrate embryos exhibit pharyngeal arches, which in fish develop into gills, but in humans contribute to structures like the jaw and ear. These shared developmental stages suggest a common ancestry, with modifications occurring over evolutionary time. Additionally, the concept of heterochrony, evolutionary changes in the timing of development, illustrates how shifts in developmental timing can lead to significant morphological changes, further linking ontology and phylogeny. Recent studies using digital organisms have provided insights into the relationship between ontogeny and phylogeny. In these models, researchers observed that traits arising earlier in a lineage history tended to be expressed earlier in the development of individual organisms, supporting a form of recapitulation. The prenate is an intelligent designer within, shaping their form with precision and purpose. This idea is supported by extensive evidence from developmental biology, aligns with the concept of self-organization, wherein biological systems spontaneously form ordered structures and patterns without external guidance. In the light of philosophy and ethics, the prenate is a subject, not an object, a being with dignity, presence, and rights. The question of when a prenate acquires personhood and corresponding moral status is a central issue in bioethics and philosophy. Some philosophers argue that personhood begins at conception, granting the prenate full moral status and rights. The perspective draws from natural law theory and the belief in the inherent dignity of human life from the moment of conception. Conversely, others, like Marianne Warren, propose criteria for personhood that include sentience, emotionality, reason, capacity to communicate, self-awareness, and moral agency. And according to her, prenates do not meet these criteria and therefore do not possess full moral status or rights. The legal recognition of fetal rights varies across jurisdictions and is influenced by philosophical and ethical consideration. In some legal systems, prenates are granted certain rights, such as the right to life, which can influence laws related to abortion and maternal behavior during pregnancy. For instance, some jurisdictions have enacted fetal dignity laws that aim to protect the prenate from abortion and other forms of harm, reflecting a belief in the prenate's inherent dignity and moral status. The ethical debate surrounding fetal personhood involves balancing the rights and autonomy of the pregnant father with the moral status and rights of the prenate. Proponents of prenatal personhood argue that recognizing the prenate as a person upholds their dignity and right to life. Critics contend that such recognition can infringe upon the rights and autonomy of the pregnant father, leading to ethical dilemmas. Feminist philosophers critique traditional models of personhood and they say that they emphasize individualism and autonomy, proposing relational models that consider the interconnectedness of individuals and the importance of relationships in defining personhood. The presence of a prenate can influence family dynamics and relationships. For example, the emotional states and behaviors of the pregnant mother or pregnant father can affect the prenatal development, and this in turn can impact the family's experiences and interactions. This reciprocal relationship underscores the prenate's role as an active participant in family life, influencing and being influenced by the family system. The prenate is a thou, not a it, to use Martin Buber's terms, calling us into ethical relationship rather than utilitarian use. Philosopher Martin Buber's seminal work, I and Thou, introduces the distinction between two fundamental modes of human engagement, the I-it and the I-thou relationships. In an I-it relationship, individuals relate to others as objects to be used or analyzed, treating them as means to an end. Conversely, an I-thou relationship is characterized by mutual recognition, presence, and dialogue, where each party acknowledges the other as a whole being with inherent dignity. Buber's philosophy emphasizes the importance of the I-thou relationship in fostering genuine human connection and ethical engagement. He posits that such relationships transcend utilitarian considerations and are foundational to meaningful existence. Extending Buber's I-thou philosophy to the prenatal context invites a profound ethical consideration. The prenate is not merely a biological entity, a need, but a subject, a thou, deserving of recognition and respect. This perspective challenges reductionist views that treat the prenate solely as a collection of cells or a potential resource. Instead, it calls for an ethical relationship that acknowledges the prenate's inherent dignity and potential for personhood. This approach aligns with feminist critics of traditional individualistic models of personhood. Feminist philosophers argue for relational models that consider the interconnectedness of individuals and the importance of relationships in defining personhood. Such perspectives support the view that the prenate, as a subject in their own right, calls us into an ethical relationship that transcends utilitarian considerations. Applying Martin Buber's I-thou framework to the prenatal context invites a shift from viewing the fetus as an object to recognizing it as a subject. The prenate, furthermore, is a moral compass, inviting society to reconsider freedom, responsibility, and care across generations. Research indicates that an individual's moral development and behavior begin with and are influenced by prenatal and perinatal experiences. Any design or model for a moral education must acknowledge the formative influence of these prenatal and perinatal experiences on later moral development. If we want a child to grow into an adult capable of moral behavior that contributes to the good of self and society, early formative experiences that facilitate such behavior are desirable. The absence of maternal presence during early development can have profound effects on the moral compass of future generations. The absence challenges preconceived notions about parental roles, urging a deeper philosophical inquiry into the responsibility of shaping future generations. By offering both theoretical and practical insights, this perspective serves as a crucial guide in navigating the moral challenges of contemporary society. This absence of mothers is especially urgent in the now. As technology keeps developing, and as the information is already out for artificial wombs ready to start work in the near future, this absence of mothers can create lots of issues for these children that will be cultivated in technological appliances without the engagement of another human parent. Moral development encompasses the principles of how individuals treat one another within society. The prenatal being serves as a moral compass, inviting society to reconsider concepts of freedom, responsibility, care across generations, parenthood. Early prenatal and perinatal experiences play a social role in shaping an individual's moral development, influencing their capacity for moral behavior that contributes to the good of self and society. Understanding the moral status of the prenatal human being and addressing ethical issues related to prenatal care are essential in fostering a society that values and nurtures moral development from the early stages of life. In the light of epigenetics and ancestry, the prenate is a bridge between the past and future, inheriting genetic and epigenetic imprints from ancestors while also rewriting them. This has many implications for health and disease. Understanding the mechanisms underlying epigenetic inheritance and reprogramming is crucial for developing strategies to promote health and keep disease at bay across generations. By recognizing the prenatal period as a critical window for epigenetic programming, we can inform public health policies and clinical practices to support maternal and fetal health. In the light of culture and storytelling, the prenate is a character already present in family narratives, imagined, dreamt about, sung about, and woven into stories before birth. Expectant parents often engage in imaginative practices, envisioning their prenate and integrating them into family narratives. Studies have shown that pregnant women frequently experience dreams involving their future children, reflecting their hopes, anxieties, and anticipations about parenthood. These dreams can serve as a means of processing the impending changes and forming early emotional connections with the unborn child. Storytelling about pregnancy and childbirth is a prevalent cultural practice across various societies. These narratives often serve to transmit cultural values, expectations, and experiences related to parenting. In many cultures, the unborn child is already considered a part of the family and community, with stories and songs dedicated to them, reflecting their anticipated role and significance. Family narratives play a crucial role in shaping individual identities and understanding one's place within a familial and cultural context. The prenate is often included in these narratives, with family members sharing stories about their conception, anticipated traits, hopes, and dreams they have for the child. And these stories help to establish a sense of continuity and connection between generations even before the child is born. The prenate is a mythic archetype, often embodied within cultural narratives and myths. The prenate symbolizes profound themes of arrival, transformation, and destiny. These mythic representations serve to elevate the prenatal being beyond mere biological existence, positioning the prenate within a tapestry of cultural and spiritual significance. Such archetypal representations underscore the prenatal being's role as a harbinger of future potential and the continuity within cultural traditions. Joseph Campbell's concept of the hero's journey outlines a universal narrative pattern involving departure, initiation, and return. This archetypal journey is mirrored in the prenatal experience, where the unborn child embarks on a journey from the safety, quotation marks, of the womb, departure, undergoes the trials of birth, initiation, and enters the world to fulfill their potential, return, while another journey is even earlier, with the before or around the conception time. These stages resonate with the mythic narratives found across various cultures, highlighting the prenatal being's role in a larger transformative journey. The prenatal child serves as a catalyst for the transformation of expectant individuals into parents. Through the development of prenatal representations and the experiences during pregnancy, the prenatal being actively participates in shaping the identities of the mother, father, other societies, the globe, guiding them into their new places. Recognizing the prenatal period as a time of active identity formation underscores the importance of supportive prenatal care and support systems that foster positive prenatal development, preparation, and parental preparation and development. Thank you. See you next time.